So, at a time when companies want to get ahead of their rivals by developing quality software, the eagerness to implement DevOps and hire engineers skilled in DevOps is at the highest. So this session is dedicated to each and every one of you who is interested to learn DevOps and start a career in this field. My name is Vardhan, and on behalf of Edureka, I will be conducting this DevOps training for you. Let me get started by first showing you the topics that I will be covering in today's DevOps demo class. So the first topic that I'll talk about is the various challenges that come with software development, especially with agile development. And after that, I will talk about what exactly DevOps is. What kind of challenges of agile does DevOps overcome? That is nothing but the need. And then I'll talk about its rise to prominence. I will of course talk about various DevOps tools involved, and there are 5 different tools which I'm going to talk about in detail. And those tools are Git, which is a source code management tool, Selenium, which is a testing tool, Jenkins, which is an integration tool, Docker, which is a continuous deployment and a containerization tool, and Ansible, which is also a continuous deployment, but which is a configuration management tool. And after I'm done talking about these tools, I will talk about the structured DevOps training that you will receive at Edureka. Okay, so if you guys have any doubts during the session, then I request you to put that in the chat box. And in the meanwhile, let me get started. So as expected, the first topic is what are the different software development challenges? There are plenty of challenges, okay? But no matter what the challenge is, the root cause for that challenge is one. And that common reason is there's a silos that exists between the development team and the operations team. Because traditionally how software was being developed was that, be it in waterfall model or be it in agile model, we'll have 2 different teams. Okay, so you'll have a development team which will only do the development of the software, and then you will have an operations team which will basically take care of deploying that software or provisioning that software to your clients or your customers. Now, since there's a silos that exists between these 2 teams, there's going to be a lot of challenges. Okay, so I have a question here. Rajesh is asking, what is silos? Rajesh, silos means there is separation between those 2 teams, okay? Or let's say that these 2 teams work in isolation. The development team would just do their part of developing the software, and the operations team would do their part of deploying that software, and they're not working together for one particular cause, okay? I mean, their end goal is the same, but they're not working together to achieve that task. That's what silos means. And because there's this silos between these 2 teams, whenever there's any problem that occurs, right? Whenever a client or a customer complains that you have your software which you delivered has this problem, then that time what happens is there's a conflict within your company. Your development team would start pointing fingers at your operations team. Your operations team would start pointing fingers at your development team, saying that it's your problem and we are not the ones responsible. And since there is this blame game that takes place, there's a lot of chaos there. And well, chaos is not good, right? I mean, it's not helping the team spirit. And the blame game is just going to make things worse. And the next time there's going to be bad blood. People are not going to talk to each other. And well, the client is the one that's going to get affected at the end of the day, right? Because he's not getting what he wants. And the company's business would eventually go down. And DevOps is something that overcomes all these problems. But before I tell you how DevOps overcomes these problems, let me talk a little more about the various challenges that generally these people face. Let's start with developers. So the number one blame game that takes place is that the developers would say that there's a bug not in my code, but the problem is what you have deployed in your production server, right? So whatever you've deployed, that's where the problem is. And then the operations team would say that, well, whatever code that you've given me, I have not modified it. So how can the problem be at my end? So if it's your code, it's your bug and you fix the problem. This is the kind of communication that happens between these 2 teams, right? If you look at it, then neither of them are at fault. So even the developer team is not at fault. Maybe the software is actually running well at his machine. Maybe it's the dependencies and the packages which are not up to date in the production server, because of which the software is not working well in production server, right? So the developer team is technically not to be blamed, and neither is the ops team. And well, even though nobody is to be blamed, the problem is eventually there, right? And you cannot take the blame away from either of them. They both are equally responsible for whatever problem that's caused. And that needs to be solved in one way or the other. And that's what DevOps aims to solve. The developer team have more problems, like the legacy system which are being used. I mean, they are developing their code on probably the best software, right? They're writing the best software and they are doing it on the best machines. But if the ops team is using legacy systems, which is very common because a lot of teams today are not moving out of their legacy systems because of various factors which they fear. That's one thing. And besides the legacy systems being used, they complain of there being tool turbulence. And there's tool turbulence which causes a lot of problems, right? They cannot use a lot of other tools, and there are a limited set of tools which the operations team would give the green light for. But unfortunately, if they cannot use it, then they just cannot use it, right? It's not going to be in use, and they're going to have a tussle eventually. The developers would, ask for automation in place. They would say that how they are supposed to do things, that's how they want to go forward. But yeah, that again maybe a hands down from maybe a thumbs down from the ops team. And if you look at what's happening on the operations side, they would say that monitoring any application is tedious. So even though we need automation, the problem is security, right? We cannot have monitoring being done by any other application because of a lot of security issues, a lot of confidential issues, and all those things. And they would also get back to the same point that you got to fix your bugs and then we won't have any problem. Whatever it is, you have to deploy it to production. So build your application based on how it is in production environment. And this is basically what happens throughout, and there's no solution to it, right? But one clear solution which eventually came out is the unification between these two teams. And that is exactly what DevOps even represents, and what DevOps even stands for. DevOps is the solution. What does DevOps do? DevOps does continuous development, continuous testing, continuous integration, continuous deployment, and of course, continuous monitoring of the software throughout its development lifecycle. With DevOps, you don't have like multiple people, right? You won't have two different teams who are working in isolation. The development team and the operations team is one team now. They are called the DevOps team. And the DevOps team could probably consist of a group of individuals doing the same thing, or it could contain a group of individuals who are doing one single thing, right? So one person maybe is taking care of development and the other one is taking care of operations. But they will make sure that they are aware of exactly how things are going to happen. They'll make sure that the environment is consistent, and probably they will have to take ownership for any problem. And more responsibility simply means less errors, and that is good for business. That's what the DevOps strategy emphasizes on, right? And what you see here on the left, this is the DevOps lifecycle. There you will first plan whatever software you want to build, whatever application that is, and then you would code based on whatever your plan is. You would collect all the system requirements and all the software requirements from your vendor, and then you will code based on that, and you will create binaries and executables so that the code can be easily deployed to your production servers or staging server or any other remote server. And once your code is built and ready to be deployed, you would first test that application, right? And then you would perform whatever unit test or integration test, all sorts of tests to make sure that there are no bugs. If there are any bugs, they would be immediately integrated back to your planning or coding phase and make sure that those bugs are fixed. But in case there are no errors, then that would be then integrated to deployment. And from the deployment phase, once it's in deployment phase, basically your customers or clients are getting access to it. And whatever they are doing, however the system is performing, everything is going to be operated on and monitored. And once it's monitored, whatever bugs we think that the software is coming up with, whatever shortcomings or drawbacks the software has, and whatever problems the clients they face, right? Whatever expectations they needed and what they don't have, everything is noted down, and all those problems are fixed in the next in the next iteration, right? So that's why we have something called as a feedback loop over here. Through the integration, whatever bugs are raised over here, those are sent to the planning phase, and the whole cycle continues, right? So you have the second cycle where you will plan, code, build, test, and the features would be tested, and then it would be deployed, then operated, monitored, and then the next sprint or the next cycle would continue. Okay, so it's a never-ending symbol. So if you look at it in a way, it's an infinity symbol, right? That's how DevOps actually stands. That's the DevOps logo. And that's what is represented here also. It's a never-ending cycle. And the never-ending cycle basically is because of the integration phase, which holds the entire DevOps structure in place. So that is about the DevOps strategy. Guys, any doubts here? So Kumar is saying that the image on the right has the same guy doing two different things. Well, Kumar, yeah, that's just a representation where we are saying that the same guy is doing both the development and analyzing, and he'll also be the one that will deploy to production or do the reporting or whatever, right? So it's basically giving that one particular person more responsibility and more power over what he's doing. Okay, so that is about the DevOps strategy. If it's all cool, then I'm going to move forward. All right. So in brief, there are various lifecycle phases in DevOps, and we will consider that the first two phases, which is the planning and coding phase, to be the continuous development phase, where work will always be ongoing in developing your application. All right. And then you have the continuous testing phase, and the testing phase also includes the build and the test. The build, because this is where you will build your executables, your binaries, your packages, everything would be downloaded and made sure it's ready when the code is deployed. Okay, basically packaging your code along with all the dependencies it needs. And then when it's built, it would be immediately tested. So that's what continuous testing refers to. And once your testing is done, next is all about integration, where this goes. If there are bugs, it would go back to your planning and coding phase. If there are no bugs, it would go to your deployment phase. And in your deployment phase, we have it called as continuous deployment, where you will be doing two things, which is deployment, and after deploying, you will do the operations. And when you operate, you will have to monitor also. And monitoring is one of the most important aspects, because if you want to improve your software, then this is the place where you go to, right? And your customers and clients would also given your feedback, and when that feedback is given, that would be integrated with the help of this phase back to your planning phase. So that would be planned and coded and done here. Okay, but the thing you have to remember is the monitoring phase, which is really important, because you don't want your customers or clients to come up with problems. You want to proactively monitor your application and fix the bugs before they come to know and before they complain. So that's why this part is very important. So that's about the different phases. But now let's see what are the different tools which are used by the topmost DevOps engineers in today's world. Okay, so we have the same set of phases, but now let's start with the tools which can be used in each and every phase. Let's start with the planning and coding phase. So planning and coding, we have various tools called the version control tools. And those version control systems are examples of those version control systems are Git and GitHub. We have SVN, then we have Jira, and we have many more, but yeah, these are the most popular ones. And Git is the notable winner here. Okay, undoubtedly Git is the one that is the best in the market, and this is the most used because of its various integrations with other tools and other lifecycle phases. Okay, you will be able to write your code over here and then share that particular code with multiple developers of yours. Your team, how many developers are there, with every one of them you can share that particular code. You can collaborate with them, and you can maintain a revision basically of whatever you've coded. So your whatever you've worked on is never lost. So these are the tools, right? And for building, we have various tools like Maven, Apache Ant, and Gradle. Now, what we mean by building is basically that these tools will help you download all the binaries and packages which are needed by your code. So if your code has to run, right, then it needs certain libraries and certain packages. Where your functions would be present, where your inbuilt libraries would be present. So your building tools would do that. It would make sure that your code has everything that it needs. And after the building phase comes your testing phase. So in your testing phase, we have Selenium and TestNG. So Selenium is the automation testing tool, and TestNG is another tool which supports Selenium in various places, right? It complements Selenium because Selenium has a few shortcomings like test case management and report generation and a few other things. And that's where TestNG is like something that's used along with Selenium for performing testing. That's how it works in the industry. So that's about TestNG. And then for integration, of course, we have various tools like Bamboo, Hudson, and Jenkins. But please note, Jenkins is the standout tool. It's again the most used DevOps tool. And I would say that Jenkins is that tool which holds the entire DevOps structure in place. It integrates basically these four different phases. Okay, it has plugins to basically all of the tools. It has integration available with different phases, and various advantages are there with Jenkins. I will talk more about Jenkins when I get to Jenkins. Okay, for now, just keep that in mind. And moving on to the deployment phase, we have 6 different tools which I'm going to talk about. But the first 2 tools are Docker and Kubernetes. Now, these 2 are both deployment tools, but in deployment, they are containerization tool. That's because they deploy in the form of containers. They deploy the application in the form of containers. So they are called containerization tool. And then we have these 4 set of tools, which are nothing but Puppet, Chef, Ansible, and SaltStack. And these 4 tools are configuration management tools. And configuration management, again, is deployment in one way. But the difference is that whatever application that you want to deploy, you can deploy to remote machines, and you can quickly or efficiently scale the number of servers or the machines you want to deploy your application to. So, I mean, all the 6 tools do deployment, but yeah, that's the difference, containerization and configuration management. And moving on to the last part, which is nothing but continuous monitoring. For monitoring, we have tools like ELK Stack, Splunk, Nagios, and many more. The most popular is Nagios because it's very old, but of late, the ones that are catching the trend are ELK Stack and Splunk, right? So ELK Stack it's the open source version, and Splunk is the paid version, but these 2 tools work very similar. And I would say these 2 are the best right now if you want to do monitoring. So monitoring is done by basically analyzing your logs, analyzing your system's health, your application's performance, and many other things. So these are the tools which are used. And if you guys know these tools, then you're good to go, right? So you are a DevOps engineer. But then here comes the question, if I'm Alice, right? So on the left is Alice. And if I'm Alice, then I would have this problem as to should I learn all these tools, right? And even if you are thinking in the form of, if you're thinking as Alice, if you're in her shoes, you would be wondering, there are like some 20 tools or 30 tools out there, and should I have to learn every single tool to become a DevOps engineer? And the answer is no. You don't need to learn every tool, because a lot of these tools work in a very similar fashion. So all the configuration management tools work similarly, okay? And even if you know one tool among these 4 configuration management tools, then you're good enough, because a company would not be implementing all the tools. They would be probably implementing one containerization tool, maybe one configuration management tool, maybe one continuous development tool, and maybe one continuous testing tools, and one out of the continuous integration tool. So it's important that you know at least one tool from each of the these phases, okay? And just to sum things up, we have Git, Selenium, TestNG, Jenkins, Docker, and Ansible. So these 6 tools is what I will be talking about in detail going forward, okay? And let me start with Git and GitHub, okay? So Git and GitHub, like I said, is a continuous development tool where you can build your code, where you can store revisions of your code and share that code with a group of members, could be your team, okay? So GitHub is the version on the cloud, and Git is your local installation. So basically, what is Git? Git is a distributed version control system for tracking changes in your computer. Okay, when we say tracking changes in computer, it's not just going to be restricted to code where developers or programmers would be building. It could also be any sort of file, like a Word file or a presentation, or basically any file, right? Whatever files are there in your system, if that is a Git repository, then versions of that file can be maintained. What changes you made the previous day and what you did the day previous to the previous day, everything will be maintained. And if you want to suddenly switch to your state, what was the 2 days back, then you can easily switch back to that day. And that's what basically a version control system does for you. And the best part is this is shared by multiple users, okay? Multiple people can be coordinating together, building on that particular code, okay? And they can share, the code base is shared with them. So how is it shared? It's shared because they will all be deploying, or they will all be committing their code to one particular server, which is nothing but which is in a distributed manner. And this server, in case of Git, it's called a distributed version control system. Distributed because people can access this server from anywhere. They can access it from home, they can access it from any part of the world, as long as they have the internet, okay? If it's a centralized version control system, then you can access that particular server only from your office LAN, right, from your office network. And that is a problem, because you will have the dependency of coming to your office. You cannot work from home, you cannot do anything else. If there's an emergency and if you want to quickly fix your bugs, then you cannot do it. You can do it from home with distributed version control systems. And Git is one, and that's why Git is a highly popular and highly used tool. So this is your server or your repository where everything would be present, okay? But then you have local repositories also. Supposing these 3 are the local working machines at your end, let's say workstation. So if there are 3 developers, then these are the 3 different workstations these 3 developers have, okay? And each of them would be working separately on their own code. And once they work on their code, what they can do is they can commit their changes to their local repository. And once the changes are recorded to your local repository, from there, those changes can be pushed or pulled to your central repository, okay? Your central, but your distributed repository, okay? So that's your server. And we have various commands like push and pull, which does the coordination over there. And then you have your commit or update, which does the coordination over here, okay? So first of all, from your, whatever changes you make from your system, that has to be pushed to your local repository. And from your local repository, your push or pull has to be made to your central repository. Okay, in our case, it's going to be a distributed version control server. So that's what is Git, and that's how multiple users can use it at the same time. Okay, now let me just revise whatever I spoke about by talking about the benefits of using Git. First of all, there is team collaboration, because a lot of people can be contributing to your code base from different locations, maybe, or from the same location. But the point is, they can contribute, and you will have one single database where a lot of people will be sharing their code. And this developer team who's sharing the code could have any number of people, like 30 or 40 or 50 people. And they can also be present from anywhere in the world, right? So that's the advantage. Second thing is that there is revision control. So whatever changes you make, a version of that would be stored, right? A copy of that particular change would be stored. So if I have X today, and tomorrow if I have X plus 1, and tomorrow if I think that X plus 1 is not good enough, and if I want to switch back to X, then I can efficiently do that. Right, so I have something called as rollback, where I can switch back to my previous version and I could just go back to X, and I'm all back to normal, right? So my bugs, whatever would have come up in that x plus 1, then that is gone, right? And I don't have any other problems. So that's revision control. Third is backup. Because everything's on the server, nothing is lost. So even if your local machine crashes, then you can be rest assured that your central server is not going to face the same thing. And the fourth thing is analysis. There are various benefits, because if you can analyze whatever you've coded and whatever you've whatever features you've developed, then you can analyze your basically you can analyze your tool, you can analyze whatever you've built, and you can come up with better versions of it. Okay, so those are the different benefits of using Git. Now moving forward, let's look at a use case, and it's going to be a use case about this company called Orbitz. So what and who exactly are Orbitz? Orbitz is an online travel site which is operating in over 180 countries. Okay, and let's see what was their condition or situation before they moved to Git. Since they are an online travel site which is very similar to an e-commerce company, and of course which is operating in over 180 countries, if there's any bug even for 1 second, or if there's a downtime of their servers for even 1 second, then that will result in millions of dollars. Okay, and that is definitely not welcome when it's serious business. On a deeper level, let's see what exactly their challenges are. The first thing is that they have over 40 feature teams which are working in parallel. Okay, 40 different teams which are doing coding at the same time. Okay, now that's the number one problem. The second is these developers use a centralized version control system for working on the same code base. Now all these 40 feature teams need to be present at the office to be able to access this particular centralized VCS. Okay, that's the number one problem. And of course, this particular VCS that they are using, right, the centralized VCS, it was not scalable. That was a big problem that they had. And if they had 40 feature teams, then they could not accommodate a lot more, and they were restricted to manpower. And another problem is that the developer to code deployer ratio is 50:1. These were the problems that they had before Git came into the picture. Okay, now remember, Git is a distributed version control system, and with Git you will not have this problem. Okay, they can access the code from anywhere they want, and Git is scalable, and Git can let multiple people working on the same code base, because it's not going to be the local server, it's going to be a remote server, the cloud, the internet, where you're going to be deploying. And because it's going to be the internet, the capacity is very high. Now let's go into details and talk about what exactly happened after they moved to Git. Since Git is a distributed VCS, it helped them in scaling the systems globally. If they had 40 feature teams initially working in parallel, then they had to be present in the same geographical location. But with Git, they could have probably 50 more feature teams, and those could be located in geographically different places. Maybe in US, maybe one team in India, maybe one team in Australia, and something like that. And the next advantage is that Git allows these developers to branch and merge flexibly. Now that means that you will have multiple teams, and they will be working on the same code base, but if they had to eventually merge the code together, then they had options to do that. They could do branching and merging, and it didn't require any extra effort to get all the code together. Git gives you this option to branch and merge code which is there, which is coming in from different developers. And Git helped them achieve automation because it could be effectively or easily integrated with other tools, like your testing tools, your integration tools, also with your deployment tools, and most of the other tools. Git had plugins. And the next advantage is that Git helped decrease their build time by more than 20%. And that was thanks to the implementation of Stash, which is a Git repo management solution. Okay, so this is your main highlight, letting them decrease their build time by more than 20%. Okay, that's how Orbitz moved to Git, and that's the success that they face with Git. So now that I've spoken a lot of theory, let me go show you a demonstration of this thing. So for the demonstration, let me move to my virtual machine. Okay, so do give me a confirmation if you can see my virtual machine here. Okay, so this is my Ubuntu virtual machine, and this is my terminal. Okay, so let me do an ls first, and you can see that I have a Git repo over here. Okay, so for the demo purpose, I've already built a Git repo, or let's say technically I've already initialized a Git repo where I have a file already present. Now what I'm going to do is I'm going to make changes to this particular code and show you how the changes would be immediately reflected on my GitHub. Okay, so first let me move to this Git repo ls. Okay, so I have my hello world.sh. I'm going to do a cat hello world.sh. So I have 2 lines of code, one basically specifying that this is going to be a bash file. Okay, so that's for my Linux, Unix, for shell purpose. Okay, but the one code which I have is echo hello world. So I don't have any major code. Since it's a basic tutorial and introduction to the DevOps tools, I've just had a simple line which says echo hello world. Now let me open up my GitHub account also in the meanwhile and show you that this same line is present over there. Okay, so let me verify the same thing from my GitHub repository. So for accessing GitHub, let me go to my Firefox and say go to github.com, and yep, I'm currently logged into my account. So let me go to my repositories first. Okay, so actually hello world is the repository which I'm talking about, and the hello world file that you see here, right? So this is the file that we have over here. So there's echo hello world, and the same thing we can see here, echo hello world. Now what I'm going to show you is I'm going to make a change to this particular file, and this change will be immediately reflected in my GitHub account. Okay, it's going to be cool, right? So if you're new to Git, then of course this is cool. So first of all, let me open this particular file. Let me say sudo gedit hello world.sh. So here goes my password. So we have this, and what I'm going to do now is I'm going to say this is line number 1, all right, and I'm going to enter a line number 2 and say echo hello from Edureka, and let me add another line saying, but first let's say line number 3, and here let me say echo your instructor. Oops, your instructor is Vardhan. Okay, so yep, let me follow it up with this smiley here. Okay guys. Okay, so I'm just gonna save this file, and let me close this. I'm gonna clear this, and let me do a cat hello world.sh, and now you can see that we have these 2 extra lines. In fact, this third line is modified, so we have 3 new lines over here. Okay, now what I'm gonna do is first let me show you the GitHub account, and let me refresh it for you. And yeah, so there are no changes right now. Okay, you can't see any change, but give it a minute, because what I'm going to do here is going to impress you. Let me clear this, and first let me add the commands to first push it to my local repository, and the commands for that is git add -a. Okay, now remember this flag A is going to have a capital A. Now that you're done, you have added your changes to your local repository. Okay, now it's time to commit your changes. So the command for that is git commit -m. So -m basically stands for message. Git commit is good enough, but if you want to find out what is the change, then for namesake, you just are giving a name to your particular commit. So in my case, I'm going to say this is my DevOps tool, or let's say DevOps tools session. Okay, intro to DevOps tools session. Okay, perfect. Okay, so now let me hit enter, and as it says, 2 files changed, 3 insertions and 4 deletions. Based on whatever was there, I've made those changes. Okay, so don't worry about all these things, but the good news is some changes been tracked by my system, and that's all I want. Now I've done my changes to my local repository. Now I have to push it to my Git repository, and for that we have a command called git push origin master. All right, so when you hit enter, it asks for your username and password, because Git has to basically authenticate which user account I am pushing it to. Okay, so it's been linked to my GitHub account, so I'm gonna basically enter my username and my password. So first let's, okay, Vardhan NS. Okay, and then the password is this. Okay, so now that my changes are committed to my central repository or my Git repository, let me refresh the same file, and you would find the new lines over here. So like I said, line 1, line 2, line 3 with all the modified ones, right? So this is what I did, and yeah, and this is the comment, like I said, intro to DevOps tools session, right? So this is how Git works. So that is pretty much the basic demo that I wanted to show you. Now let me move on to the next tool. Okay, but before that, let me just clear the screen out. Okay, and let me exit this. So getting back to my slides, I spoke about Orbits, and now let me go to the next set of tools, which is nothing but Maven, Selenium, and TestNG. Now Selenium is your main tool which does your testing, but we have Maven and TestNG, because Maven is your build tool, and TestNG is going to be the tool that supports Selenium and test case management. Okay, so in the industry, TestNG is heavily used, and I'm going to show you how it works. So the first thing you have to note is that What happens here, right? Whatever is done with the help of these four tools, it's called as continuous testing, because automation testing is basically automated, which means it's going to be continuous, right? So whatever your testing is, if you automate your testing, it's called automation testing. And the very act of automation testing, if that is done in a continuous manner, then it's called continuous testing. And these are the four tools which are involved: Maven, Selenium, TestNG, and Jenkins also, because Jenkins is the one that is going to do the integration. So that will be so you'll be able to integrate it with your other tools. So let me show you a demonstration of these tools first. So Maven for continuous testing. Now, like I said, Maven is a build tool. Okay, it's going to be useful for building. Now, what building means is that it's going to help you manage your project structure efficiently, and it will help you download the dependencies and libraries which you have mentioned in your code. Now, supposing I'm writing a code for, supposing I'm writing an Angular code, then my Angular code would need a lot of dependencies, right? A lot of boilerplates and all those things. So if I mention that in Maven, then I can download that. But yeah, that's just an example that I gave you, all right, with Angular. In general, you can do anything, especially for Selenium. Okay, in my demo, which I'm going to show you later on, is a Selenium demo where I have mentioned Selenium and TestNG dependencies in my pom.xml file. So your pom.xml file is your is technically your Maven file, and your pom.xml file, if it has the dependencies mentioned, then it will download those dependencies, and then your code will then run successfully, because those will be the dependencies your code needs, right? So that's what Maven does. It downloads your dependencies for you and lets you execute your code without any problem. When it comes to Selenium, it is the main tool which is used for testing. It does web testing, and it does web testing only. Okay, it's not used for testing your desktop applications. For web pages, websites, and web applications only. That's what Selenium WebDriver does. But it has a few limitations like test case management and report generation. Now, if you're working on a very big tool, or if you have an extensive project which you are testing, then you will have this problem, because your code is going to be very big. It's going to involve multiple test cases, and in that case, if you want to find out which test case passed, which one failed, and if you want a report of everything, then you're going to have a slight problem. Okay, it's going to be slightly tedious, and to overcome these problems of test case management and report generation, we use something called as TestNG. So TestNG is a tool which complements Selenium with these problems. And yeah, tools like Maven, TestNG, and Jenkins can be integrated with Selenium for performing continuous testing. Okay, but you have to note that Selenium is the most important tool which does the actual automation testing for you. And moving on to TestNG, let me reiterate that again. It's used with WebDriver for overcoming WebDriver's limitations like test annotations, which helps in managing your test cases. Okay, and it lets you create or generate structured test reports. You will get to know if you have like 50 test cases, it will tell you exactly which test case failed. And if you know exactly which test case failed, then it's easy for you to locate your bugs and fix your problems, right? So that's the advantage. And TestNG helps perform unit testing. That's something which you people already know. Now, moving on to the last tool which is used for testing, we have Jenkins. And like I said, it's the tool which lets you connect to other parts, right? So your automation is done by Jenkins. It's the tool which does your continuous testing. Actually, it enables continuous testing. Okay, what Jenkins does is it lets you schedule your builds and deploys the code to production or to staging server or to testing server based on those builds. Supposing your testing failed, then it would basically send a notification to your developers, whoever developed the application, would talk about the bugs and why the error occurred. And if your test case passed and if it was successful, then it would just build and deploy that particular code to the production server or the staging server or whichever server you want it to. And the best part about Jenkins, it can be integrated with most of the testing tools. So I'll talk about Jenkins in a little more detail, but before that, let me just go and show you a demonstration of how these tools work together. So like I said, we will have one TestNG XML file, but this TestNG XML file will be called by your pom.xml file. Okay, so we have two XML files here. The pom.xml file is used by Maven, and over here you would say which TestNG XML file to execute, and you will say which are the dependencies which are needed for executing the code in that particular TestNG XML file. So the dependencies would be downloaded over here, and the code which is present here, that would be executed. And coming to the testng.xml file, what it does is it would say which is your Selenium code, and it would be able to first execute your test cases. And as and when your test cases are executed, your TestNG helps you analyze whether your test case is passed or test cases failed. That's the most important thing, right? You have to verify if your test case passed or if your test failed. And TestNG does that for you. It tells you if your Selenium test case is passed or failed, and it gives you a very brilliant report. Simple, easy report which you can understand, and your job is very simple. That's what is the benefit with this XML file. And like Selenium is the most important tool which basically does your testing for you, and whatever the result is, that is automated, or the future steps, the build steps are taken care by Jenkins, and that's why it's continuous testing. So let me again show you the demonstration, but the demonstration has to be shown on Eclipse this time. Okay, I'm not going to use my VM. I'll load on my Windows machine, and I'm going to use my Eclipse. So I have again opened up my TestNG XML file, my Maven.the pom.xml file, and then my Selenium code. Okay, this is my Selenium test case. So I have everything present. Let me just explain what's going to happen on a high level. So first of all, I have various packages which I've imported. These are among the libraries which I've imported, and everything is present in this particular package of mine. When we say package, it's basically the repository where this class is present and where these libraries would be present. This is the place where it's present in my local repository, okay, in my workspace. Now getting to your main code. So my class name is Edureka demo, and over here I have @test, which is basically an annotation, and this is what lets me test if my test case passed or test case fails. Okay, so this is the role of TestNG over here. Now the code over here, this is all about Selenium. Okay, even the assertion which happens here, it is taken care of by Selenium. Now TestNG, what it does is, if this assertion passed or failed, that would be analyzed by my @test annotation, and that would be reported to me later on in my report. And with that, I achieve both report generation in an effective way and automation for testing. Now let me explain my code and tell you what exactly I'm doing. So the first is just a println statement which says, hi, this is Vardhan, and this is a very simple explanatory line. When it comes to testing, what I'm doing is I'm first of all setting my system property. Now why should I set my system property? I have to set it because I will have to work with one of my drivers. If I want to do testing on one of my web pages or some given URL, I have to open up that URL using one of my browsers. So in this case, I'm using my Chrome driver. Okay, I'll be doing the test on Chrome browser, and I'm going to use the Chrome driver, which is going to basically control my Chrome browser. Okay, and the command to set that property is webdriver.chrome.driver, which would say it's time to perform testing on the Chrome browser, and I'm just specifying the path where this particular Chrome driver of mine is present. So it's present in C users, Vardhan downloads, and this is the name of the file. Okay, chrome driver.exe. And once I've set my properties, the next thing I have to do is I have to create an object of this particular WebDriver class. Yeah, so I'm creating an object instance of this particular driver class, and I'm doing it with this. Okay, this is the command WebDriver driver is equal to new Chrome driver. So I've created my driver instance for my Chrome driver, and that's this object. And now I can straight away perform my task. This is again a very simple testing where I'm going to ask my driver to navigate to this particular URL, newtools.demoaut.com. Okay, so this stands for demo automation, and this is a testing page which lets us test. Okay, and what I'm doing here is I'm getting this page title. So every page will have a page title, right? So on top of the tab, you will see there's a name that comes up. So that is what it is. So I'm creating a variable called title, a string variable called title, and here I'm storing the page title. So the driver.get title, right? So the get title is a function which is basically imported with one of these packages, and this is going to do this for me. It's going to obtain the page title and store it in this particular variable. And what I'm going to do is I'm going to assert if this is true. If the page title I'm getting from my Chrome driver, is it the same as this welcome : Mercury Tours? Because if I open up my Chrome, so let me open up that URL, newtools.demoaut.com. So this is the page title, and the page title is welcome : Mercury Tours with a space. Okay, and I have to make sure that the page title is equal. So I have initially fed this is my expected title, welcome : Mercury Tours, and I'm saying whatever is obtained over here, this has to match whatever is expected. Okay, expected and actual. So that's it. That's a simple assertion. And since I have @test, this TestNG would bring out a report saying that this particular test case, okay, so whichever method is present or whichever method has this @test annotation, that particular method has passed or not. So if the actual and the real values are the same, then this test case would pass. But however, if the title which my driver is getting and if this is different, then it will fail, and that would make my test fail. Okay, so that's how things are going to work. So this is my Selenium code, okay, but we have to use Maven and TestNG, right? Because that's how the industry works. And the reason we are using TestNG is because in this case, it's going to be very simple. You just have one simple code that we had. You just have one test case, and you can just use one @test annotation. But in case you have like hundreds of thousands of test cases, and you'll be dealing with an actual website or a web page, you have to test all the functionality. So in that case, you'll have to use a testng.xml file where you can mention which all classes you want to execute. Okay, that's a very brilliant option that we have. And as you can see here, I've done this, right? So we have a suite name, test name, and class name. But first, concentrate on this class name over here. So what I have here is I've said execute this Edureka demo. Okay, so this is a class name. I'm saying execute this particular class which is present in this particular package. Okay, so that's the format. Your class name would have to be specified in this format where you have the package name dot your class name. And if your package name, again, if you have different directories inside your package, then it would be separated with a dot. So maven.selenium.testng.jenkins.edureka demo. Okay, so that's how things work. Okay, and I can have multiple classes executed like this. So this is one class, okay, which I've closed within these tags. So if I open one more tag over here with saying class, then it means that I'm executing a second class. And like this, I can execute any number of tests. So my one test can contain one or more number of classes. And similarly, this one particular test can be contained inside this particular suite. And pretty obvious, but this suite can have more than one test. So this particular suite of mine will have one or more number of tests. This particular test would have one or more number of classes. Okay, and in this classes, I can have tags inside the class tag where I can have one or more number of classes. So that's how simple it is with your XML files. Okay, this is your testng.xml file. Now, if you want to execute this testng.xml file with the help of Maven, you have to write a pom.xml file. Okay, so this is the pom.xml file, and the template is like this. So this is how a pom.xml file would look like in general. You have a few things here which you have to remember, and those things are your group ID and artifact ID. So these are the things that will change. Okay, the remaining things would pretty much be the same. The only things that will change are the ones which I'm going to explain now. So the first thing is your group ID and your artifact ID. So your artifact ID is basically the package where it's present, okay, or your workspace repository. Okay, and of course the name of the class which I want to execute is Edureka demo. All right, and once I'm done specifying where the class is and where it's present, I have to specify the testng.xml file which I want to execute. So my testng.xml file is going to be present over here, okay, inside my package. So I've just specified the name over here, and I've specified it inside these tags of suite XML file. Now this suite XML file I'll explain it later. Okay, so why it's present inside the properties tag, I'll explain that later. Now coming down, I've specified where my code is present and what I want to execute. So now it's time to specify the dependencies, right? So I have basically two different dependencies. One is TestNG dependencies, and the other is Selenium dependencies. And my TestNG dependencies can be called with the help of this group ID of this and artifact ID of this. Okay, you will find this in the internet. And similarly, for downloading my Selenium jars, these are my dependencies. So again, these come under a dependency tag like your TestNG dependency, and these two dependency would again be inside these dependencies tag. Okay, so you have a dependencies which opens here and which ends over here. And once you've specified your dependencies, you can simply do the building over here. Okay, in your build and in your plugins, you can say what you want to basically run. So there are two things which you have to remember. There is Maven Surefire plugin which you have to specify, and your Maven compiler plugin. When these two are done, then you're ready. These are your Maven plugins which need for others to work. And if you come down, you have your configuration. So your configuration is what controls which XML file you want to execute, and the XML file which you want to execute, you would have to specify it within your specifying that the XML file which is present inside my suite, this suite XML file is what is there here. Okay, so inside these tags we have executed on specifying this. Okay, so my plugins, build and project, everything, all the tags are ending over here. So that's how simple it is. Now let me execute this Maven file. Now the fun part is the Maven file can be executed through your terminal. Okay, so let me open up my command prompt for that. So right now I'm here. So I'm going to say cd workspace. Okay, so maven.selenium.testng.jenkins. So this is where I want to go. I'll hit enter. So if I do a dir, then I will get to know what are the contents, right? So I have my pom.xml file present here, and I have my testng.xml file present over here. So this is what I have to execute. So I have to execute my pom.xml file. So the command for that is, actually the command is just Maven, but before I execute the pom.xml file, I have to make sure that I clean whatever my previous build was. So for that, we have a command called Maven clean. Okay, mbn clean basically removes whatever is there in my cache. So ambient clean will do that for me, and it would let me build my project next. Okay, so let's just wait for this command to execute successfully. Okay, building Edureka demo. Okay, so this is done. So now what I'm going to do is I'm going to do a Maven install. Okay, ambient space install. So this is the command which builds your project. Okay, it's going to download all your dependencies. So if I hit enter, all my dependencies would download one after the other. If I have it already, well and good. If I don't have it, then the dependencies I mentioned over there, they would all be downloaded. Okay, so it would use these plugin, the Maven resources plugin, the Shortfire plugin, and the compiler plugin. Okay, so let it get completed. Okay, perfect. It's running my test. Hi, this is Vardhan from Edureka, and it's opening up my Chrome now. Okay, my test is gonna run now. So this is my Chrome opening up. Wait up for it to open up the new tools.demo page, and then the page title would be verified. This is the page I was talking about. Title should have been verified by now. Okay, so let me just minimize this window, and you can see that my build is success and it's finished over here. Okay, perfect. So this is how a Maven test works, and this is how you do it using your Windows command prompt. Now that my task with respect to these three tools of Maven, Selenium, TestNG is done, okay, but I'm not showed you with Jenkins. So the next tool I'm going to talk about is Jenkins. So when I talk about that, I will execute the same file using my Jenkins, okay, and show you how the execution of the continuous integration happens over there. So this is the end of my demo with respect to continuous testing. So let me just close this particular Eclipse of mine, okay, and let me open up my PPT. This is what I finished, and yeah, I will continue that demonstration of Jenkins when I talk about Jenkins in detail. So Jenkins for continuous integration. Okay, so what exactly is Jenkins? Jenkins is a continuous integration tool which is used for automating various stages in your DevOps lifecycle. And automation is basically achieved by using plugins to various tools involved in the process. And this is why Jenkins is the best, right? So you have everything that you want. You can automate your various stages in your DevOps lifecycle. If you have a building phase, you can automate this part. If you have a testing phase, you can automate this phase. If you have a deployment phase, that can also be automated. Same thing can be done with the deployment, the monitoring, and your development. And how is this automation actually done? It's done because it has plugins to basically every single tool out there. If it's a DevOps tool, then you can be pretty much sure that Jenkins has a plugin to that particular DevOps tool. And since it has so many options, that's why Jenkins is the most used CI tool in the market. This is the leading tool, hands down, no doubt about that. If there's one DevOps guy who tells me that he's not using Jenkins for CI, then well, no, something's wrong with that person. Okay, no offense to other tools, but Jenkins is just that good. There has to be a really strong reason for anyone to not use Jenkins instead of some other CI tool. Okay, so Jenkins is that popular, and that's about Jenkins, right? So it's a continuous integration tool. But how does Jenkins work? I mean, if you're a newbie, and I'm pretty sure you have doubts, right? So like Rajesh is already asking, I mean, what actually happens here? So let's answer that question here by seeing how Jenkins works. So you as a developer would first commit your changes to your source code, okay, which could be on Git or SVN or some other VCS tool. Once you commit your changes to your source code, okay, so this is your source code, various developers. Once you commit your changes over here, you will have your continuous integration server or your Jenkins server, which will trigger a build based on that particular commit. Okay, since you did a commit, it would trigger a build, and that build would involve pulling the code. And once the code is built to that particular server, the next thing it does is it deploys it to the testing server. Okay, so the build application is then deployed on the testing server for testing. And at this point of time, if there are any errors or if there are any bugs or any shortcomings, then you have a feedback loop from which all the feedback is taken and it's sent to the developers. Okay, so if the test case fails, your Jenkins server would notify the developers by sending an email notification. Okay, so that is why we are saying CI is good. So that is the feedback loop. The email notification to the developers is the feedback, and they will be able to rework on the code and the build phase. So that's about the testing phase. But in case of your test is a success and there are no errors, you can still configure there to be a notification to be not to be gone to the developers. But in general, what happens is the same application is then deployed to production server or any other server of your choice. Okay, it is deployed to the production server, and once your production server is also deployed, then whoever the concerned teams are, they are constantly notified about the build and test results. So the testing and the building would again be happening in a regular fashion. So that's why it's continuous testing, right? So you might be testing probably every night, and you will be expecting the results as and when you come to the office the next day morning. So that is how Jenkins works. Okay, pulling and deploying, and it makes place for your feedback loop. So that's the working of Jenkins. Now let's talk about a case study of Jenkins, and let me show you how it actually impacted this famous company called Nokia. So before they were using Jenkins and before they were using continuous integration, this is what they were. This is how they were working. Okay, so they had something called as a nightly build, which was their way of building and integration. And what happened here is every night they would have an automated system, and that system would pull the code which is added to the shared repository. So the developers would be there, and all the developers would commit their code to a shared repository. Okay, and they would be doing it throughout the day, and thus they would build a particular code. And since this particular code was built throughout the day, and various applications would have functionalities for various applications would have been defined, and a lot of other build packages should have been downloaded, all those things would have happened. So you have code and various dependencies which should have been downloaded, but of course it didn't happen. Okay, and it's waiting till the night, and during the night this particular code, which is a very huge code, okay, since the code that was built at night was quite large, locating and fixing bugs was a real pain. I mean, yeah, like I said, you have a real big code and you have various dependencies for that particular code. So everything would be done at the night. All the dependencies for that particular code is downloaded, and the entire code which was built is tested over here. Okay, and once you test it, that's when you find out your bugs, right? You have to do your debugging. And the problem is, since you have such a big code, finding your bugs and checking where your bugs basically are was a real pain, because there's so much code and there are a lot of developers who are contributing, and it's tough to differentiate and tell which developer or tester should work on which particular code, right? So that's the pain. That's what they were facing at nightly builds. Okay, this is what was happening at Nokia. But when Jenkins came in, right, so the Jenkins CI server solved the majority of this problem, because they don't have to wait till the very end of the day to do your build, right, to trigger your build. So what Jenkins does is, as and when a developer commits his code to the repository, immediately a build is triggered. And as and when the build is triggered, that particular developer would be notified of the error or the bug that is there in his code, because some test case would have failed. And if that test case failed, then he would have known where exactly the. And when Nokia started using Jenkins, the situation was a little different. So as you can see, Nokia adopted the continuous integration server as that comes with Jenkins. And when Jenkins was in use, for every commit a developer used to make, immediately build used to get triggered, because they used to wait till the very end of the day. All the jobs would get triggered at the same time, and then if there are any bugs, it was tough to locate. But since in this case, when Jenkins was in use, since the jobs were getting triggered immediately, what used to happen is, if there were any bugs, those could be reported immediately, right? It was easier, and each and every developer, whoever used to make the commit, that person would get a custom email notification saying that your commit has been whatever you had committed, from there's been a bug detected, and this kind of test case passed or this test case failed. So it was very specific and it was very to the point, and that's why using the Jenkins CI server made a big difference at Nokia, right? So that is about the use case. Now let me show you a demonstration of the same. Now for the demonstration, let me open up my Chrome first, and let me open up my Jenkins dashboard. Okay, so this is my Jenkins dashboard. So Jenkins is usually active on this port number, okay, localhost 8080. But you can change the port number. You can change it as per your wish, but by default, this is the custom port number that Jenkins is active on. And as you can see, this is my dashboard. Okay, and so for our demo purpose, I've already created one project. This one you can see here, right? Maven, Selenium, TestNG, and Jenkins. So this is the one which I created, and here I've configured things already. Okay, so let me just show you how the project works. Let me go to configure here. This is where you can do all your settings with respect to Jenkins. Now, one thing which I might have skipped at this point of time is that I have created this project as a Maven project. So whenever you want to create a new project, you have to click on this option here, okay, new item from your Jenkins dashboard. You click on new item, and then you can enter your project name, and you can choose Freestyle project or Maven project or any of these options. So in my case, I have chosen Maven project because my project involves Maven and it involves execution of a POM file, right? So that is why I chose Maven project. And once you do that, you will get this tab, and in this tab, yeah, you enter the name here, and if you can just go to the source code management tab, you can enter other options if you want to pull it from Git or SVN. But anyways, what I want to show you first is let's go down to the build tab here. This is the place where you have to specify where your POM XML file is present. Okay, so I have specified this path, users, Vardhan, workspace, and then the path, the project directory where it's present, right? So Once I've fed this path, we have to specify what are the two commands that you want to run. Now, since it's a Maven project, I don't need to specify mvn clean and mvn install separately. Okay, so we have goals and options, and since it's a Maven project, it's pre-understood that these arguments would be added with mvn. So we can just simply specify clean with the space. You can just specify install. So this would execute two commands. First, it would execute the mvn clean, and then it would execute the mvn install. So earlier from my command prompt, I did those two commands separately. In this case, that's the benefit I have with Jenkins. Okay, I can just specify the two arguments I want to run, and the POM XML file would then be executed. Now, the other thing which I would also want to show you is that if you come down to the post steps over here, we have email notification option. So if you check on this, you can choose which email ID you want to be sent to. And the email ID could be sent in case of there's a failure in the execution. So if your build fails, or if for every unstable build, you can send the email. So that's what I've done here. You can do that, or you can choose to get an email even if your build passes. So what usually happens is when you go at the end of the day, you might want the testing to start. So you will have Jenkins to start the testing, and in the morning when you come in, whether the test case passed or not, you might want the reports. So usually people do this. So they would ask for the email reports, and Jenkins would send it to them, whether it passed or failed or whatever, and then you'll just get the report. All right, so that's how it happens here. And so now that I've shown you this, let me just quickly go on top and show you the execution of this thing. So let me click on build now. So when I click on build now, my pom.xml file would be actually executed, and this time I don't have to do it manually through my command prompt. Jenkins is doing it for me. So my project is being built here, build number 297. Okay, so if you go to console output, you'll get the actual console which you usually get on Eclipse IDE. So this is what I used to get earlier, right? So yeah, first it's executing the first command, mvn clean, and then mvn install, and yeah, just wait up for the entire thing to complete. So if you notice, it is the same log which came earlier, right? So whatever came on the command prompt, we have it here now. But there's just one thing which you people might should notice. Actually, there's one difference with respect to executing it on the command prompt. Does anyone here know what that is? Rajiv, Akshaya, anybody? So Rajiv says that the Chrome window didn't open up. Does the actual testing actually happen? So Rajiv, the thing is with Jenkins, you don't get the Chrome window, right? And that's what I wanted you people to notice, because earlier you will have your Chrome window popping up, and the whole thing would happen, right? The testing would be visible to you. But in case of Jenkins, that does not happen, because Jenkins is considered to be a server, right? It's a CI server, and usually when you're having such builds in a remote server, probably a cloud server, then you don't need a GUI. In fact, you won't have a GUI. So why do you want some Chrome to open up and show the whole process, right? So that's why with tests with Jenkins in general don't have the Chrome window coming up. Okay. So anyways, as long as you see this result, right, finished success, that's the most important thing. Your build is a success, and the same thing which happened earlier has happened now. Now getting back to my project here, I showed you how to execute it manually, but when we use Jenkins, we use it because we can schedule the builds, right? So that's the power of Jenkins. So that is something which I have not showed you yet. So if you go back to configure, there's an option of build triggers. Now this is what was the best part about Jenkins, and this is what Nokia used, and that's why Jenkins is so popular. You can choose when you want your test cases or your jobs to be built. You have an option to build periodically. So check on this box and you'll get this option. Okay, so here you have to enter when you want to do it in cron format. So for those of you who don't know what a cron format is, I would request you to please Google what cron format is and just learn that. Okay, because it will take me too much time if I start explaining that. And let me just simply tell you that cron format is simple. You will have 5 different parameters. Okay, the minute of the hour of the day, date of the month, and then day of the week. So there are 5 different options that you have. And if I say something like this, right, with 5 asterisks, it means that I choose to execute it at all these times. Asterisk basically means all or every. So if there is asterisk in the first place, then it means that execute or build the job for at every minute of the hour. Okay, be it 0th minute or be it the 59th minute, the job will get built. Okay, and if the second option is asterisk, then it will execute at every hour of the day, 0th hour and till the 23rd hour. And same thing, if there's an asterisk over here, day of the month, then the explanation is straightforward, right? Every day of the month, and in this case it would be every month of the year, and in this case it would be every day of the week. If you want to customize this, and if you don't want the builds to basically execute during the weekends, then you can choose not to have asterisk here. And if you want to customize these things, and if you don't want your jobs to be basically built or get triggered during the weekends, then you can do that too. Let's say you want the days on which you want the builds to be happen only on Mondays to Fridays, then you can choose the days of your week. Monday is basically my first day, right? So 0 is Sunday, 1 is Monday. So I can say this: 1, 2, 3, 4, and 5. I can do this. With this, on my 5 different days, this build will get executed, right? My job will get built. And this is how cron format is. If I don't have asterisk here, and if I have 1 in this place, then the build would be triggered basically only on the first minute. So please just look up how the cron format works, and then you'll be able to play around and work around with this. Now, what I'd rather show you is if I replace this with asterisk, and if I save this, then see what happens. It's 1:30 now. Basically, for every minute from now, the build would start getting triggered. That's what's going to happen. Okay, so just wait up. You can verify the same thing from here also. So here it says that with asterisk, the last time this would have ran at is at this time, April 19th at 1:30. Okay, and the next time this is going to run is again at the same time, because it's going to basically run every single minute. So right now it's 1:30. So just wait up. When it's 1:31, you will have another job that gets triggered over here. Yeah. So did you see this trigger coming up on its own? That's because of the trigger which I had set over there, right? That's because of the cron format. I wanted the build to be built to execute basically every minute. And similarly when it's 1:32, the same thing would happen. The build would start getting triggered again, and this thing is never ending, right? So that's what happens with your triggers. And if in case your tests fail, you will get an email notification, and you will get to know that okay, whether this happened or whether that happened. So let me just close this for now and then save it, so that I don't want it to be running completely. And also note that my previous execution, it's a success. So my ball is blue in color, so it's all good. Had it been red in color, that means my build would have failed. Okay, so that's the meaning over here. That's it with my demo on Jenkins. All right, so let me go back to my slides and continue with my PPT. So the next thing that we have for today is Docker. Now, what is Docker? Docker is considered a containerization tool. Okay, but as a containerization tool, what does it do? It basically does deployment, right? So it's very similar to configuration management tools like Ansible, Puppet, or Chef, and Ansible, SaltStack. Docker does something similar, but does it in a different manner. Okay, so the end product is, yeah, deployment, but the whole deployment here works by containerization. So let me just read the definition once again. Docker is a containerization platform which packages your application and all its dependencies together in the form of containers. Now, what that means is, for your project to run, you might have a particular code which basically runs your project, and along with that, your code will have various dependencies, right? If it's Angular or Node, then you will have various boilerplates which have to be there, and various libraries which have to be downloaded. Now, all these libraries, all these boilerplates, along with your code, right, they will be packaged together, and they will be packaged in the form of containers. So basically your containers will only contain these things and nothing else. Okay, even the memory allocated to your container, and even the space that would be allocated to your container would be only for these purposes and nothing else. But in case of virtual machines, it works a little different, right? In VMs, you allocate a little more. You allocate space and you allocate RAM to the VM itself, and then the VM after that allocates memory and the RAM to your application. But that's the advantage with Docker. Nothing extra is consumed, because you're not giving anything extra to the Docker container. You're only giving the container how much your application needs. So that's what you see in the architecture diagram here. Okay, now this is how Docker usually runs. You have a host operating system, and on top of that, you have your Docker engine running. Okay, and then your Docker engine would power multiple containers. So take, for example, container 1, you have the application 1 running, and this is basically running with the help of the binaries, the code, and all these associated items. Okay, and whatever contents are there in this container 1, they are limited and specific only to container 1. Another container running in the same Docker engine cannot access this unless and until you want it to access. Okay, they're all specific now. They're all just separate. But there are options where we can have one container interact with another container. So in that case, we would open port numbers and we would say that, yeah, do whatever you want, right? So that's what Docker is. And speaking of the benefits that Docker has, the number one benefit is that the RAM that is consumed by Docker is very less, for the very reason I told you earlier. With VMs, there is some extra RAM that you allocate to your VM, and there is also some extra space which your VM will take. because what your application needs, that much RAM and memory would be allocated by your VM, but your VM will also have something extra, right? So that is of course underutilized. Now that's allocated to your VM, but it's unutilized. So since it's unutilized, that memory goes for a waste. But in case of Docker, you'll not have that problem. That RAM or that space will not be occupied at all. It will not even be allocated. And with Docker, it's also easy to run the applications, because once you need to do this, once you have to set up your Docker environment, and once your application is running, all you have to do later is run the container to get your application active. And if you want to stop your application, then just close the container. Okay, stop the container and kill the container. And all these are one single line commands. You don't have much to do. But in case of VMs, you might want to start or boot the different VMs or the different servers, and then get the application to start running inside them. Now, maybe to run the application, you will again need a couple of commands. Now the benefit is you don't have to run all those commands every time when it comes to Docker. With VMs, yes, you have to run all the commands in those servers or VMs. In case of Docker, just start the container, and then whatever commands which are needed to run the application, those would be started or specified on its own. That's the thing. And most of all, these containers are very lightweight for, again, reasons obvious. And since they are lightweight, they can be easily shared. You can either upload it to your Docker Hub and share it with your collaborators, your fellow developers, or you can do one more thing. You can just export your container into your machine. You can export it to a tar file and then share that tar file to another person. And then that person would import that tar file into his Docker engine, right? And then he has the Docker image. And then by just running one command, he spends a container of that particular Docker image. Now that is what Docker is, and that's why Docker is really beneficial. Okay, along with Jenkins, yeah, Docker is one of my favorite too. And I love Docker because of the benefits that it has and of the power that Docker has. And now moving on to talking about how do we create these Docker containers. We basically use a Docker file. Okay, you can either pull a Docker image which is already present on a Docker hub, and then you can run a container out of that image. Okay, but in that way, you're not creating your own Docker image. You're just using a custom, you're using a default image which is already there. Okay, if you want to start your own application, then you have to build your own Docker image first. Okay, your own Docker image for your application, and that Docker image is built with the help of a Docker file. So that's what it says, right? Your Docker file will have all the commands which are needed to build your Docker image, and it will also contain all the project codes and all those things. It will have the place where your project codes are present. That would be present in your Docker file. And you can create a Docker image out of that particular Docker file, and then you can use that one Docker image to create any number of Docker containers. You can create 10, 100, any number. As long as your system has that much of bandwidth and it has that many resources, you can start any number you want. So that's how Docker works. Okay, and this is a diagrammatic representation of the same. You have a Docker file, and then this Docker file is used to create a Docker image, and then this Docker image can be made into a Docker container. Just execute this Docker image, and then you have a running instance of that particular Docker image. So the running instance is the Docker container, the inert version is the Docker image, and this Docker image can be shared with other people also. You cannot share the Docker container. Okay, so Akshay has asked a question, can we share the Docker container? No, you can share the container, but yeah, it's not the container per se which you're sharing. You are sharing the Docker image, which is like a template. So think of it as a template, Akshay. Once you share the template with your other collaborators, it can be either by uploading to Docker Hub or by export and import. You can do one of these things. Once you give it to the other person, then on different servers, on production server or on staging server, this person can run this Docker image and get the running instance of this image. The running instance is the Docker container. So they can do the execution on their end. Okay, so that's how it works. Your doubts cleared? Okay, perfect. Okay, so that is it with my theoretical part. Let me quickly go to my VM and show you a demonstration of Docker. Okay, so it's the same VM which I showed my earlier demo on. And let me first bring up my terminal. So I hope my console is visible now, my terminal. The first command that I want to run is docker ps. And what this command does is it lists down all the Docker containers which are running. Let me just clear the screen and run it again. So right now there are no Docker containers running and nothing is active. So that's why there are no entries. Now, however, if I include the A flag over here, docker ps-a, then I would get listed down all the containers which were ever active in my Docker engine. Even the stopped containers, they would be visible. So as you can see here, I have a number of containers here. You have the container ID, image from which it was spun, the command which was used to create them, and then we have the created day, the status, port number, all these details, right? So there are containers which I started a few days ago. And then we have some which were started a few months ago, and yeah, many more like that. So that's how this command works. If you want to see the Docker images which are present in your Docker engine, then just simply run the command Docker images. And then yeah, all the images which you can consider to be templates, they are listed down. So using any of these Docker images, I can create their respective containers. So we have a demo app one, we have a mean stack app, which I of course have showed demo on previous videos, and those videos are there on YouTube, so you can watch those videos. And then there are many more images here, out of which we can create various containers. But I think for today's session, I will show you a demo on this one particular demo app of mine. Where am I right now? Okay, I'm in /home/Edureka. So let me just list down all my folders. There's this folder demo one. Now the demo app which I'm talking about, it's an Angular application basically. On a particular port number, it's going to launch an Angular application of mine. Let me bring up that application first, and before I do that, let me do a cd, go to this demo one folder, and here let's do ls. I need to actually go to this folder, cd demo. So let me do cd demo, and do I have what I want here? Yes, top movies. So this top movies is the Angular application I'm talking about. It has details about probably the best 250 Hollywood movies ever. Okay, so it's our ratings. One of our folks at Edureka created this project, and it's, as far as we are concerned, this is what we think are the best English movies ever. So let me just show you that. All my project codes are present here. I have an src folder. I have a package JSON file which basically starts my container. Okay, it has details about everything, whatever is needed for my Angular application to run. And then there are node modules. So this is the folder where all my libraries and boilerplates are present. And then I have all these things. With respect to Docker, I have my Docker file here. Okay, so this Docker file lets me create a Docker image for this particular application or project of mine. And once this Docker image is created, I can spin a container. I've already done it before, but let me just go about the steps and show you how it actually works. So let me do a gedit and show you the Docker file. I'll show you what are the lines which are present inside my Docker file. A typical Docker file would look like this. Always the first word would be in caps, and this basically means, when we say from, it means I'm asking my Docker engine to download node as a base image. Okay, from is used when you want to specify the Docker base image that you want to build your application on. Okay, and then you have other commands like run, working directory, copy, and all these things. So when you specify run, it basically means that, so this directory would be created inside my Docker container. And then what I'm saying is change the working directory to this particular directory. So make this my working directory of my Docker container. And then I'm saying copy the package.json file which is there, copy it to inside the container. So if you see over here, there's a package.json, right? I'm saying copy this inside my Docker container. So that is about this particular line. Okay, and after that, I'm simply running these two commands which I use for my npm. So npm is my known package manager, and I'm saying first clear all the cache, and then I'm doing an npm install. So when I do an npm install, my package.json would be used to download all the boilerplates and whatever dependencies are needed for my application to run, and it would just set my environment up. When I do copy with the full stop and then this directory, it means that copy everything, all the files which are present in this particular directory into my container directory over here, okay, which I've set here. So I'm copying everything into this particular container of mine. And after that, I'm saying expose my particular port number 4200, meaning my Angular application would be hosted on port number 4200 of my Docker. And by specifying this command npm start, I'm basically running my Angular application. So that is technically the final step to start your Angular application. Okay, even if it's a node application, whatever. If it's a mean stack application, also use npm start. So that's what I'm specifying here through my Docker file, command npm start. Now, if I execute this Docker file, then all these commands would be executed in turn. And when all these commands are executed, I get what I want, right? My application is also active. How is my application active? Because a Docker container is running. So let me do the first thing. Let me execute this Docker file and create a Docker image for this. So there we go. Let me just clear the screen. Since my Docker file is present in this particular path, let me run the command to create a Docker image using this Docker file. So the command is docker build -t followed by the image name. So if you remember, my image name is demo app 1. So I'm going to use the same name, and then I'm going to say that particular Docker file to build this Docker image demo app 1 is present in this particular path. Full stop or dot here represents the same path, same directory. look for the Docker file in the same path. But if my Docker file is not present over here, if it's present somewhere else, then I would have to specify the path of my Docker file here. If it's in /home/Edureka, I would say instead of this dot here, I would specify /home/Edureka. If it's in root, I would just specify the root path here. So let me hit enter. This would start building my Docker image first. So step 1, step 2, step 3, 4, 5, 6, 7, 8, 9. I've already built this before, so that's why it was pretty quick. Otherwise, if you're doing it for the first time, trust me, it will take a long time. Okay, but yeah, I have my Docker image ready, so lucky me, right? Let me clear the screen and run the command docker images. So you can see this, right? Demo app1. So this is the same image which we built now. Let me run this image now. Okay, when I run the image, I will get a container. So the command to run this image and get a container is docker run --rm, and okay, --rm basically tells that run this container in recursive mode. That's what it means. Okay, so remember to use this flag. After that, use the flag -p and do the port mapping. Now, for those of you who don't get it, hold on for a minute. Let me explain what port mapping is. If you remember, I told you that the Angular application would be active on one particular port number, right? So in the Docker file, I said port number 4200 because I want my Angular application to be active on port number 4200 of my Docker container. Now, in case I want to access it, then I cannot access it on my VM because I'm running a VM. If I want to access this particular application, then I have to access it on Docker's port number. So since I can't do that, what I'm doing is I'm asking my Docker's port number 4200 to basically share whatever it has on this particular port number of my web, okay, or this particular port number of my VM. So here basically I'm mapping my host port to my container port. So with this, I'm asking my system that on my port number 4200 of my host, on this particular localhost 4200 over here, whatever is active on this particular port number, that has to be visible over here. So let's say that in my Angular application is, since it's running on port number 4200 of my Docker container, I'm mapping this to my host port 4200. Okay, that's all it is. And after this, I need to just simply say what is the image I want to run. In my case, it's demo app1. So if you hit enter, my container would eventually start getting built, and then it will be active in just a couple of seconds, or maybe more than a few seconds. So just hold on until that happens. So basically my ng serve is just started and it's telling me that it'll be active on this particular IP address, right? So 0.0.0.0 basically refers to localhost on my own machine. And since I said port number 4200, I can access my application over here. So either put in this Firefox or mention localhost :4200. Both mean the same. And yeah, my project is almost built, 92% done. Okay, bingo. Webpack compiled successfully. This is the message that we usually get whenever we run any main stack or Angular application. Okay, so let me just go to my Firefox and open this particular IP and port number. So yeah, this is Firefox. Over here, I'm going to type in localhost. Yes, 4200 is right here. When you hit 4200, the Angular application is up, right? So this is my Angular application I was talking about. So yeah, that's how things are, right? So you can access whatever you want, and whatever needs to happen would just happen. So that's how easy and that's how effective Docker is. Okay, you can easily spin containers like this, have get your application to be built on the Docker image, and once the Docker image is ready, share it with everyone you want, and then your application would be easily working. Even if you want to scale it, you can use Docker Compose technique to have to scale up your number of containers, and then if you want to have them on remote machines, you can again use Docker Swarm for that. So Docker is one really amazing DevOps tool, I would say. Love the Docker tool, and probably when you try it yourself, then you will know how brilliant it is. So for now, let me show you one more thing. Let me do Docker PS again, and this time if you see the container which I just started a couple of minutes ago, that entry is there here, right? Since I didn't give any name for my container, so it's taken a default name. That usually happens. We have the image name though, so that is the thing. If I want to like manually stop this particular container which is running, then from the new tab I can just run the command docker stop, and I need to specify the container ID. Copy, paste. So yeah, my container has now stopped. You can see here, right? So this is the entry has gone, and if I go back to my Firefox and refresh the page, yeah, the application is lost. That's because I shut down my container, and by shutting down my container, my application has also been shut down along with it. Okay, so let me just clear my screen, and now let me get back to my slides, and let's go to the next topic, which is continuous deployment again, but this time the deployment is with Ansible. So what exactly is Ansible? Ansible is a configuration management, deployment, and orchestration tool which automates your entire IT infrastructure. So it's a push-based configuration management tool. Now, what this means is that I can have one system. Okay, so my system, which can be a controlling machine, which is a Ansible controlling machine, and I can have any number of machines, any other servers or remote servers, which we can say, those will be my Ansible hosts. Okay, if I want to suddenly scale up my servers, and if I want to deploy an application on these many servers, then I can do that. What I'll be technically doing is I will be deploying my configurations. So I can deploy my configurations on any number of servers, and in my case, I will be deploying probably my configuration in one other server. Okay, that's what I'm going to do in my demo. And Ansible is called a push-based configuration management tool because whatever configurations or code you want to execute on remote machines, right, by scaling up, that is done in a push manner. So from your controlling machine, you push your configurations to your other hosts. In your controlling machine, you will specify which are the hosts that you want to run the script or the code on, right? Deploy your configurations. So you will have a hosts file in your controlling machine, and in that machine, you will be specifying the IP address of the other of the host's machine. Okay, so once you do that, then to all the IP addresses mentioned in your particular host file, the configurations will be deployed. Okay, so that's how Ansible works. And so for just summarizing things, it's a configuration management tool, which means your configurations would be deployed on multiple other machines. All right, so that's about Ansible. So Ansible is also popular because it does these things like provisioning. It supports orchestration with multiple other tools, automation, it's push based, and deployment. So these are the details you have to know about Ansible. So here, let me just talk about Ansible. Let me just summarize what Ansible is by talking about its features. Number one, Ansible is simple to use because you don't have to install Ansible in all your machines, okay? Because sometimes with certain machines, you will have that problem. With Ansible, you don't have that problem. You just have to install Ansible in one machine, which is your controlling machine, which is like your master. From your controlling machine, you just need to specify the IP addresses of your Ansible hosts, and whatever configurations you deploy, it will be automatically deployed on those servers or host machines. So that's simple. And Ansible is powerful because you can do it to any number of servers. You can create any number of servers, and you can just bring them up in the blink of an eye. That's how powerful it is. Ansible is agentless because you don't have to be an external agent to always be checking for configurations. Okay, you just have your controlling machine which would do everything for you. And most of all, Ansible is efficient, Ansible is fast, and Ansible is simple. So that's about the features of Ansible. All right, so now that I've done with the theoretical part of Ansible, I'll just want to quickly open up my VMs and show you a demonstration. So for the demonstration, let me open up my VM, and in case of Ansible, I will have two VMs. Okay, like I said, one will be my controlling machine and the other will be my host machine. So this is my Ansible controlling machine, which would deploy my configurations, and then I have another machine which is nothing but an Ansible host, and this would be the one that will receive the configurations from my other machine. Okay, so I'm not going to take things make things very complicated and show you an actual configuration. What I'll do is I will do a simple ping. Okay, and now before I do that, let me first run this ipconfig command. Okay, that's because I want to identify what is the IP address of my machines. For my Ansible host, my IP address is 192.168.1.102. Okay, so over here, let me do the same thing. And yeah, so the IP address over here is 192.168.1.100. Now the reason I'm first identifying the IP address is because I have to specify the IP address of my host machine in my hosts file in this controlling machine. Okay, if you guys have a doubt, if you guys didn't get it, then just follow closely, because whatever IP address you mention in the host file, those will be the IP addresses where the configuration will be deployed. So let's first of all go to that particular host file. Okay, so let's do a sudo gedit for that. etc ansible hosts. Okay, so let me do an enter and let me give a password over here. So this is my controlling machine, right? Now most of the lines are commented out, so these are the only two lines which are not. Okay, so this is because I'm specifying a group of servers. In this case, I've just specified web servers for my reference, or you can say anything, DB servers or any server for your reference. Okay, and here I have the IP address 192.168.1.102. So this is the same IP address as my host machine. So the thing which you have to note is I can have one IP address, or I can have a set of IP addresses. Then say if I ask Ansible to deploy configurations to this particular group, then all the IP addresses inside this group will receive the configuration. Otherwise, I can do one more thing. I can just simply choose this particular IP address and say ping this particular IP address. I can do that. Or if I want to, and well, in case if I have more than one group, then what I can do is I can use the parameter all to specify that my configurations need to be sent to all of the IP addresses present in my host file, not just to one particular group. So I have all these options. Okay, so let me just close this hosts file and quickly show you how to deploy a configuration. So I'm not going to actually configure. I'm not going to actually deploy a configuration. What I'm going to rather do is ping my host machine. Okay, so that's equivalent. That's equivalent to basically deploying a configuration. Since it's a basic demo and since you people are beginners, so this is good enough. So the command is Ansible -m. Let's say I want to ping basically all the IP addresses present in my machine. So for that, I would say ping all. Okay, when you hit enter, just wait up for what happens. Yeah, so now you get it right. So the IP address 1.102 is pinged. This is a success, and that's the thing, ping pong. So this is how Ansible is used to basically deploy your configurations on multiple servers. And if it was an actual configuration, then even that would have been deployed to all these servers. But since it's a basic demo, you might not be able to understand it. So let's reserve such demos or such hands-on for future classes where we'll go into more depth. Okay. And in the meanwhile, let me just go back to my slides and conclude today's session. But before I conclude today's session, let me just talk about Edureka's DevOps course. Okay. For those of you who have yet not enrolled for the upcoming DevOps batch, then do note that on completing the course and on completing all the projects, you get certified by Edureka. Okay, and you'll get certified that you're a DevOps engineer and that you're a person who's skilled on these tools. And those tools are Git, Docker, Puppet, Kubernetes, Jenkins, Selenium, Ansible, and Nagios. So what's happening here is our DevOps course at Edureka is being upgraded. Okay, so we are adding a few more modules, and we are explaining a few more tools like Kubernetes, Selenium, and we are talking about Docker in detail. So Docker, which is right now, or which was earlier a one module course, is now going to be a two module affair. Okay, and same thing with the fact that we are adding a module for Kubernetes and for Selenium and for a few more tools. So these are our changes or upgrades to our DevOps course. Okay, and these tools are what you will be learning. And module-wise breakup is going to be this. So in the first module, you will be talking about DevOps in general. Okay, you will get an introduction to DevOps, what exactly it is and how it is in the market, and you will get the DevOps essentials. Okay, you will get it on a high level. And after that, in the second module, you will understand what is version control, and the tool that we will be talking about exclusively is Git. Okay, you will learn everything that you need to know about Git and GitHub and how source code management works. In the third module, we'll talk about Jenkins, which is a continuous integration tool. Like I told you, you will learn a lot about Jenkins, and you will be able to build a complete delivery pipeline. Followed by that is a module on Selenium, where you'll talk about how testing actually works and how it can be integrated with Jenkins and other tools. And after that, we have a module on Puppet, and then we have a module on Ansible. So both are configuration management tools. Puppet is a popular tool and Ansible is the other popular tool in the market. And these two tools are good enough for you to have a good knowledge on configuration management. All right. And then we have two modules on Docker. So since Docker is really important, we have given more time. We have emphasized that you have to learn more with respect to networking and the ecosystem aspect. So you will have a basic introduction over here with respect to containerization and all these things. And here you will learn more about Docker. And then modules 9 and 10 will be about Kubernetes and Nagios. So Kubernetes is again a containerization tool, and Nagios is a monitoring tool. So after completing the 10th module, your course at Edureka would end. Your training with respect to all these tools would be done, and you'll be skilled enough to get a job and start a career as a DevOps engineer. Okay, so at any point of time, if you guys have any doubts and if you want to know any details about our course, you can always go to our website at www.edureka.co/devops. Okay, So we provide DevOps certification training over here, and like I mentioned, these will be the various tools that we will be training you upon. Okay, so on that note, I would like to conclude today's session. So Rajesh, thank you. Amrinder, thank you for being a part of the session, and hopefully I will see you in our first DevOps training class. Okay, so thank you for attending this demo class, and bye bye until we meet the next time. Okay, so happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!